Hello everyone, welcome to the stream. Streamer actually the class ആണ്. So we'll start with today's class. വളരെ സിമ്പിളായി നമ്മൾ ചാപ്റ്റർ എടുക്കാൻ പോവാണ്. ലൈൻസ് ആൻഡ് ആംഗിൾസ്. Hope everybody is clearly know what I am going to take. So chapter, I don't know the chapter number, I think 6, so I am writing 6. Chapter 6. Chapter 6 ഏതാണ്? Lines and angles. So date, put the date 07/10/25. Can underline everything and keep. Okay, so before getting into lines and angles, in 7th standard and 6th standard we learned geometry. I think we learned understanding geometry, quadrilaterals, triangles, everything. That in 7th standard you had triangles, quadrilaterals, circles, then what? Then parallelograms, that I think that perimeter and area, something like that also that is there. So this year also your chapters are the same: circles, construction, quadrilaterals, parallelograms and triangles, triangle and its areas, lines and angles. Most of them are geometry, and geometry is a little bit hard in the 9th standard. 9th standard students will be having this chapter for your first term exam for sure, most probably, if they are going with the portions from the starting. I don't think most of the schools seminar is for Euclid's geometry. I am going to skip that chapter. Euclid's axiom and postulates can be learned. So starting with something you have learned, a point. Most of you have learned what a point is. What do you mean by a point? Referred by a point can be drawn anywhere in a plane. So how do you write a point? So I'm going to just, this is a drawing space I'm going to create here. So in this is it's a plane. Just imagine this is a plane, and this plane, this is known as point A. Depicts point A. Now line. Very prominent thing, you have heard it everywhere. Line, a line. A line is drawn by using two points. It can be indefinitely or infinitely extended. These 2 points are very easy. referred by xy. I'm gonna do xy because usually I don't think that's clearly visible for you. Give me a second. X or y, whatever you can give, so I'm just referring it as that. It is not that important that you have to refer the same thing. This is I'm starting lines, okay? Lines and angles, lines topic I'm started. Next topic is, no, it's not next topic. One thing I forgot, the rough work. Here, this is point A, this is point B, A, B. This is line AB, or what do you write? Here you do what I said, a line can be indefinitely extended to any point using, but always using 2 points we draw, then we extend it. That is the case. Okay, let me continue. Okay, so next is line segment. Till line segment and ray we are going to learn. Line segment, a line, part of a line, which is fixed. That is the referred as. How we do it? This is like this. It cannot be, line segment is not extended. A line is a segment. Okay, line in a segment and line segment in the okay. So I'm going to make a rough space here. Sorry. Okay. I will rough. Okay. Now let's continue. How do we draw? Oh, we already know. I think most of you guys will be knowing how to draw it. It's like 2 points L and M. This is it. Depicts what? Depicts line SEG, segment LM, or just draw this, then draw LM. Now ray, very easy thing. A ray is actually, I'm not going to give any definition for ray because there is no need. A ray is obtained, this is just a symbol, if the line one end is extended throughout. Just you can say infinitely. Infinitely, that's most used, right? Denoted as A, B, one thing here. Or opposite side also used, but if you can do it whatever you like, you can do it. Okay. Okay, now angles. Hello, adjacent angles, right? Or wait. Types of angles. This is over about lines that I'm going to take. Next, I will take lines again because angles first. Angle. An angle is formed using an ray. An angle is formed using a ray. I will draw an angle. Vertex. An angle P Q R. PQR. Here, this is an arm. This is a vertex, and this is a arm too. Two arms. Arms. I think usually you say arms, right? Yes. Now, an axiom for measure of an angle. Before that, an angle. Wait. Interior and exterior and all is there. So, if right. Can just leave a line and write. The two rays forming an angle is called an arms. The angle formed by the rays is okay. I will give you 3 figures. Figure. This is 1.1. 1.2. I will draw here. Then this is in. But wait. There is more issue because I will just make it a slanting angle because that is correct 90 degree, right? I'm not going to make a perpendicular angle. Here it is 1, right? But if I can draw infinite number of angles here. That is very important. Angle A E A C B, and here it is E and D. This is a representation of an angle. Here one angle, here another angle, and here a whole angle. And this full angle, you can write it as angle AEB. Angle AEB. You can say angle AEB, angle ADB, angle DCB. See, DC, DAC only, DAC. Like that, infinite number of angles can be formed here. Okay. Now figure 1.3. 1.3. Next angle. This is very important. Everything is important in this chapter, but just learn. We have to understand the base. This is angle ACB. ACB. We know. This is the vertex, this is the common, this arm. Okay. And this part is known as interior of ABC, and this part is known as the exterior of ABC. Very, very important. Just learn it thoroughly. Please give me a minute. Oh, nice. Okay. Now, congruent angles. Heading. Congruent angles. I will type the thing. Okay. Congruent angles. The angles are said to be congruent if a trace or trace copy of one can be superposed on the other hand, and to cover it completely and exactly, and exactly. Okay, this is the correct. Okay, this is the this is the thing. So I will have to give you a converse or sorry, not a converse. I have to give you an explanation on this, right? So wait. Okay, congruent angles. The angles are said to be a trace copy of one another. Two or more angles have the exact same measure. See, I don't think you will be able to understand this. Okay, so I'm not going to give you this. Okay. അടുത്തത് adjacent angles. Okay, very simple. Adjacent angles. What to form an adjacent angle? Here E is there. Okay, you need one common vertex one common arm, one common arm, non-common arms on either side of common arm, CA. Same vertex, same common arm, and uncommon arms on non-common arms on either side of the common arms. What is this? Is the adjacent angle. Okay, next. Types of angle. Right. Types of angles. Types of angles. Okay, how? Right. Right angle measure exactly 90 degrees. Acute angle, like it's 0 and angle BAC 0 90 degree. So if an angle BAC, so this should be below 90 degree and not below 0 degree. This you have to draw this figure and write 90 degree angle BAC. Then obtuse angle, complementary, supplementary and reflex angle you can draw on your own because that's very easy. I have to give you an axiom on the other thing. Obtuse, how? 0. Please wait a minute. Obtuse angle 0 90 degree comma BAC comma 180. This is the thing. So what you do is, here you will write 180 degree comma BAC less than 180 degree, but not less than 180, but not less than not equal to 90 degree. Not less than or not equal to, I put, okay, it's okay. You can draw that. Then right angle, refuse angle, then just straight angle means straight 90 degree angle. How will you draw? Straight angle, this is the straight angle, this is the straight angle, this is LMN. So angle LMN equal to 180 degree. Then this is straight angle, or you can say about reflex angle. Reflex, it's like you have to draw like this. Here the one angle form, here one angle form, anywhere. So you draw like this, and this should be more than 180, more 180 degree more. not more than 360. Okay, it should be not more than 360. Very important. Next, complementary and supplementary. Complementary is when complementary, I'll just draw complementary and I'm drawing. See, listen, this angle is exactly what is, if this is ROS, Guns and Roses, we have learned, I think, in smaller classes. This is exactly, this angle ROS exactly 90 degree. And what about SUBPL, supplementary? Supplementary angles are always 180 degrees. So what will you draw is here. But when you're drawing a complementary angle, you can just draw here a separate part for this if you want, because this thing bisects this, and this angle, if x plus y equal to 90, അങ്ങനെയാണ്. Don't know equal to 90. But this angle is 180 and this is LMN or LMO, whatever. Angle LMN is equal to 180 when it is bisected like this. This part plus this part, x plus y, should be equal to 180 degree. മനസ്സിലായോ? Okay, then 1 second. Now what is it? Angle bisector, which is the last topic in, but I didn't take measure of an angle axiom and theorem, so I have to take it right now. After that I have to take today itself everything. Linear pair, I have 3 theorems and 2 axioms. Who will take that? Okay. Angle bisector cutting an angle, always an angle bisector. I'll draw and show. This angle is bisected like this, means this plus this, x plus y is equal to xy, and y plus x is also equal to xy, because this part is divided perfectly. Very important. We need to know why. That is what is an angle bisector. Now very important things I'm going to tell, which is like, this is not this topic, I'm going back. Okay, it's this topic itself, but I have to converse the statement and all, right? No, angle, congruent angle. So sorry. Okay, so I was just checking some. It's already 30 minutes until the class. I will stop at 45 minutes, or when I finish this topic, I'll stop. Measure of an angle. So, what? Okay, this isn't completely new, different topic. Measure of an angle. You write axiom. Angle measure axiom. Angle measure axiom. I will type it in because it's a little big axiom. Every angle has a measure. No, it's not a big axiom. Every angle has a measure. A measure. The unit of an measure is known as degree. It's very simple axiom. I'll type the other one also, don't worry. Oh, sorry. Next, angle, another axiom. Congruent angle measure axiom. No need of that. I'll teach it next because this is only needed. Angle measure. That's only what we are learning now. Next, we learned about adjacent angles, everything. So now I'm going to tell you about linear pair. Linear pair has 3 theorems. Theorems, which means we have to prove it. Okay. So this proof and all, I will just. So 2 adjacent angles. This is different. Linear LPA, linear pair axiom. 2 adjacent angles. 2 adjacent angles are said to form linear pair LP. If their non-common arms, their NCA non-common arms or uncommon arms are 2 OPP rays. OPP means opposite rays. OPP rays. This is it. Then next, theorem, linear pair theorem. Linear pair theorem 1. First theorem. If a ray stands on a line, then sum of the adjacent angles so is formed is 180 degree. So, question number 1. Prove that 1 second, I will be writing the other things in the OneNote because it's more fluent. Lines and this is better. I was just taking too much time to read this. Write this. Right, guys. Question number 1. Prove that if a ray stands on a line, on a line AB that okay, wait. For A stands on line, no such that. Okay, line such that. Then, comma. Then, the sum so formed is 180 degree. Okay, so you write given. So when we are proving an equation, we have to prove. So always prove has this kind of things. Given and all we have to write. So what is given? That a ray. Okay, before I will draw the figure, but see, we have to draw a figure. A, C and B. This is like this. It's like this. D. This is D, and it is like here it's given as E. So a ray CD. Okay, here CD, which stands on a line AB. Line AB. Such that angle ACD and angle BCD are formed. Okay, what is it? A ray. Okay, if a ray stands on a line, if a ray stands on a line, so that the sum of sum so formed is 180. So a ray is like this is a ray, and this is also a ray. The CD stands on AB. We have constructed. Now this is the figure given. Without this, E is not given. So what we have done? We have to write construction. Draw ray CE bisecting AB. This is not plus, this is this. What do? We put a sign like this and this. Now to prove what? What should we prove? Angle ACD plus angle BCD equal to 180 degree. And proof. When we are starting with the proof, we write we have angle ACD equal to angle ACE plus angle ECD. Okay, your thing is like this. Here you have, and here you have A, C, B, D, again D and E. Okay, so here, okay, so here, look, angle ACD. This angle ACD is equal to angle ACE plus ECD. This complete angle, now it is bisecting CE and AB. അപ്പം എന്താ സംഭവം ഇവിടെ ACD, the whole angle, when we are drawing this full angle okay, this full angle and this shorter angle forms. So this ACE and ECD. Big reason we have to write that Reason എന്താ? What is the reason? CE bisects AB, line AB, right? So this is equation number 1. Now second, angle BCD. We know that this is given. It's already given. Very true. This angle entire BCD. Sorry, BCD. This entire angle BCD can be got how? Angle BCE, and because it bisects, angle BCE minus angle ECD. Because it's minus, look, to obtain this angle we need to minus this angle minus this angle. Angle BCE minus ECD. BCE minus ECD to obtain BCD, ECD, ECD, ECB, EBC or BCE, BCE, ECD, BCE, ECD. Due to why CE parallel to, CE bisected to. This is known as the second equation. Now, and adding equation 1 plus equation 2, we get, I will draw the figure each time so that it doesn't get missed out. I'll draw it here. A, C, B. This is a dotted line, and this is D, 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 E. And this here there is an angle. Okay. Now angle. Okay. Now how we are doing is we are adding the equation, both equations. So angle ACD plus angle BCD. We have to add both the LHS and RHS. So when you are adding angle ACD plus angle BCD equal to angle ACE plus angle ECD plus angle BCE minus angle ECD. Okay, ECD. So when you are getting angle ECD, angle ACD, what can we cut? ACD, BCE, angle ACE and angle BC, angle plus minus cancel, angle ACD plus angle BCD equal to angle ACE plus angle BCE. Very true? Perfect. These two angles are perfectly 90 degrees because those bisect. Bisector is always perfectly dividing into 90 degrees. So angle ACD plus angle BCD, angle ACD plus angle BCD is equal to 180 degree. Angle ACD plus angle BCD equal to 180 degree. Okay, now theorem 1. This is, I have proved that if a ray stands on a line, then the sum so formed is 180. I have shown the steps. Now I am conversing the statement 3. Theorem 1. If the sum of two adjacent angles is 180. The non-common arms are opposite rays. Theorem 2. I am writing T2. Converse of T1. Theorem 1. If the sum of the two adjacent angles is 180 degrees, then the non-common arms are two opposite sides. Then non-common arms are two opposite rays. Are two opposite rays. Okay, this is question number 2. This converse of T1. Okay, now we can obtain the same figure, but lightly make a change. Wait a second, how much time has it been? I started at 45 most probably, now it's 1 hour. 48 minutes only. So 1 hour we will finish. Okay, you are getting a figure. I am drawing the figure so that you can draw now. See, ഇവിടേക്ക് ഒരു D എന്ന് പറഞ്ഞ റേ കൊടുത്തിട്ടുണ്ട്. ഇത് AB ലൈനിൽ നമ്മളൊരു റേ CD കൊടുത്തിട്ടുണ്ട്. എന്നിട്ട് അവിടുന്ന് നമ്മളൊരു റേ E കൊടുത്തിട്ടുണ്ട്. Because of the sum of two adjacent angles. രണ്ട് adjacent angles എന്ന് പറയുന്നത് common vertex, common arm. Sorry, they have same common arm. Then two non-common arms on either side of the common arms. അപ്പോൾ അതാണ് നമ്മളിവിടെ ഇങ്ങനെ കൊടുത്തിരിക്കുന്നത്. Then what is given? I am going to write the given. Given is that what is given? Two adjacent angle. I am writing ADG angle. ACD and BCD such that you can put an angle sign. I am putting for both. Such that angle ACD plus angle BCD equal to 180 degree. Now to prove, what do you have to prove? To prove CA and CB are two opposite rays. That's the only thing we have to prove. What I have done, construction. Draw ray CE. If possible, let the CA and CB are not two opposite rays. If possible, then draw CE opposite to CA such that AC is a straight line. Okay, ACE a straight line alle. Angane oru draw cheyda madi construct. Now proof. Angle ACD plus angle ECD equal to 180 degree. First one, then second one. Angle ACD plus BCD equal to 180 degree. Angle ACD plus angle ECD plus is equal to angle ACD plus angle BCD. Alle? Very true. Angle ECD equal to angle BCD, but CE and CB are on the same side of CD. Therefore, the third equation is possible if CE and CB coincide with each other. Hence CA and CB are two opposite rays. Finished. This is the converse statement. Now I have we can do some questions, I think. There is one more theorem. The sum of all angles around a point is equal to 360 degree. That is a homework. Prove that angles around a straight line is 360 degree. Very easy question. I'm sitting here from 2 hours now. I have another class at 8:45. Thank you so much, dear children, for listening, for supporting the class. We have almost done a quarter, probably 1/4 of the chapter, because now we are going to move on to VOA. Then after this chapter it is triangles. So children, take care. Okay, so triangles, it's all of CPCT, corresponding parts of congruent triangle. Everything CPCT, so nothing to learn. Anganalla SSS, SAS, ASA, RHS, anything. Okay, എല്ലാം okay ആണല്ലോ അല്ലേ? Everybody understood?